Hi everyone, it's Shamila here from Can Do Teach, and in this video I'm going to be talking about order of operations. So in the last video I talked about all the operations that we know, but that was just talking about combining two numbers at a time. So when we have multiple operations in a row, we need to know which order to do them in. So you've probably learnt the acronym BIDMAS or BODMAS, PEMDAS, there's lots of different types, but really they all mean the same thing. So what they tell you is what order to do your operations in. So let's go through it. The first one is brackets. So anything that's in brackets has to be evaluated first, okay? Next we do indices, so any powers that we have. Then we've got division and multiplication. And these two actually have to go together. So there's nothing about doing division before multiplication. You just go left to right, whichever one comes up first, you do that one first. And the same with addition and subtraction, they actually go together. So you don't have to do addition before subtraction, they're kind of at the same level. But brackets have to come before doing indices, indices have to come before division or multiplication, and division and multiplication have to come before addition. All right? And otherwise, apart from those rules, we always go left to right. Okay? So I often refer to equations as kind of math sentences. So if we're thinking about maths in that way, these are kind of our grammar rules. So it's just a set of rules that tells us which bits go together and what we deal with first and what we deal with last. All right, and just like with sentences, we normally go from left to right unless something tells us to do it differently. All right, so I'll explain why I'm kind of emphasizing that point. Okay, so if you've got something like this, you might look at your BIDMAS and say that, okay, addition comes before subtraction. So I have to do this first and then this. But it doesn't work that way. Because addition and subtraction are at the same level, then we just do our normal thing and read from left to right. So we do this part first. 5 minus 3 is 2. And then add 2 to that. So we get 2 plus 2 is 4. Okay? So you have to go from left to right when it's only addition subtraction. In the same way, when we've got division, it can make a difference whether we do this first or this first. Right? So you always go left to right. So you do this first. That gives you 9 divided by 3 is 3. Divided by 3 is 1. Okay? So really important to remember left to right unless we've got brackets and indices or a mixture of multiplication and addition. So in this case, we do have a mixture of addition and multiplication. So in that case, the multiplication comes first because M comes before A. So now we're going to look at an example that has all the different bits of BIDMAS combined. And I'm going to talk about something that I think about as the bracket onion. All right? So looking at this expression, I actually have lots of different operations. So the first thing I notice is that I've got this big division divided by 9. So when we have a line like that, that's also kind of implied brackets, all right? So we have two sets of brackets here, these inside ones and the outside ones. So when you've got more sets of brackets, you start from the inside and work your way out. So the order that I'm going to have to evaluate these things in is these brackets first, then, so I'll do the addition that's inside the brackets, then the index, BI, so this squared comes second. Then multiplication comes before subtraction. So I do this third, and then this fourth. And now I've done the whole outer bracket, so I divide that whole bracket by 9. Okay, so even though division comes before subtraction, because this subtraction is within the big kind of implied brackets, that has to come before the division. So this is our 5th step. All right, so when we're using BIDMAS, that's what you kind of have to get in the hang of, is figuring out what order all the different bits happen in. So to make that a little bit easier, I kind of picture in my head an onion because it has a bunch of different layers. So I'll explain how I kind of visualize that in my head. I don't usually draw the whole picture out like this. But what I do is I look at this first step. So I know that's the innermost bracket. So I've got this innermost layer, which is 1 plus 4, okay? Then to that, I add another layer to my onion, which is squaring that first layer, all right? Then after the squared, I multiply the whole thing by 2. That's step 3, and that's another layer to my onion, okay? Then I subtract 5, that's another layer. And finally, I divide the whole thing by 9. That's my outermost layer, okay? Now, the reason I'm thinking of it as an onion is it's got lots of layers, so you can kind of picture it being an onion like this. Maybe I just have an overactive imagination. But when we lay it out like that, it's all very straightforward, line by line, right? So now you can kind of read it left to right. But obviously this is a lot more complicated than writing it out like this. So it's nicer to write it in a compact way, but when you're making sense of it, if you can unwrap it into the step-by-step, layer-by-layer kind of idea, it becomes a lot easier to solve. So I'll show you how that works in the next example. Okay, so this is where the onion idea comes in handy. Because if I want to solve an equation like this, I need to know how to undo all of the steps, step by step. So when we're evaluating an expression, we have to go in the BIDMAS order. So that means that when we're solving an expression, we have to go in the reversed order. Whatever happened last has to be undone first. Okay, and that's really clear when we put it into this onion kind of representation. So if I look at this expression on the left, I've got x plus 3 squared minus 7. So I can see that the x, we're adding 3 to the x, then we're squaring it, then we're subtracting 7, and the whole thing equals 29. Okay, so if I undo it, I have to do it, the only way to unwrap an onion is to go outer layer first, and then inner layer, inner layer, inner layer, unwrap the whole thing. Okay, so if I do that, the first layer to go is the minus 7. So if I get rid of the minus 7, that's the same as adding 7 to both sides. So I get x plus 3. So I get x plus 3 squared is 29 plus 7, which is 36. All right, so the next layer I have to get rid of is the squared. So to get rid of a squared, I use the inverse operation, which is square root. So I square root both sides. And that gives me x plus 3 is equal to plus or minus 6. All right, so finally, the last layer I need to get rid of is this plus 3. So to do that, I'm going to subtract 3 from both sides, and that'll leave me with negative 3 plus or minus 6, or just negative 9 or 3. All right, so hopefully that makes it clear why when we're solving an equation, we go in the reverse order to BIDMAS. It's because you want to undo the layers from the outside in to your thing that you're trying to solve for. Alrighty, so to summarize, BIDMAS is just a way of remembering the order of operations. So that's kind of our grammar rules for when we're working with number sentences. Alright, while you're still getting the hang of it, you can try drawing out or thinking about the bracket onion, which kind of gives you one step at a time. It's like the longhand way of writing all of the steps out in order. All right, and then if you're solving it, you know you just reverse that. So you peel the onion layer by layer to get to the thing you want to solve right in the middle. Alrighty, so let me know if you have any questions. You can write them in the comments below. Otherwise, you can find me at candoteach.com. Thanks for watching, and I'll see you next time. Bye for now.